Welcome back to another episode of Containers on the Couch. Today is actually a very special occasion. And in honor of that special occasion, I have brought candles for the birthday of Fargate. Fargate is now 5 years old. I'm going to put these out before I burn down my house. So hold on a second. Yeah, there we go. Awesome. So, welcome back to Containers on the Couch. My name is Mesh Seidel Casing. I'm joined here with Olly and Steven. I'm going to let each of them introduce themselves. Olly, do you want to go first?
Yeah, sure. So, hey, everybody. My name is Olly Pomeroy, and I'm a developer advocate on the Container Services team here at AWS.
And that leaves me. Hi, everybody. Steven Follis. I work as a container go-to-market specialist here at AWS, focused on Fargate and serverless containers.
Awesome. Thank you very much. Both of my colleagues, we work together very closely together with each other. So what are we going to be talking today? Today we say Fargate is 5 years old. What does that mean? So what is Fargate, firstly? Let's start with that.
Yeah,
so Fargate, don't know.
Yeah. So Fargate is our serverless compute platform inside of AWS. So AWS, we operate multiple different orchestrators. We have ECS, we have EKS, and within those orchestrators, we give you the option of how you run the data plane, the compute for those workloads. So you can run those on EC2, or alternatively, you can run those on Fargate. At least for the last 5 years, you can. Yeah. So. Yeah, and just jump back into the history. So what really led to Fargate is really around taking on more of the shared responsibility model and shifting that from you over to AWS. So with Fargate, you don't have to worry about EC2 of selecting specific SKUs, deploying those virtual machines, handling the patching, the updates, the container runtime management, different kinds of capacity management. With Fargate, a lot of that shifts over to AWS. And really everything below the container becomes AWS's responsibility. And so 5 years ago, AWS set off on how can we, as a cloud platform, take on more of that undifferentiated heavy lifting that we like to say, thus enabling you as a developer, as an operator, as a customer to be able to innovate more quickly, focus on your applications rather than infrastructure, and have just an easier to use container platform by taking on a lot of that infrastructure type overhead that we all know and love when it comes to container platforms.
Correct. It's for sure.
Yeah. It's kind of interesting. Like if you think most people today, when they run container platforms, they're thinking about like the number of virtual machines, scaling up and down those virtual machines, patching virtual machines. A lot of that goes away with service like AWS Fargate, because like all you're worrying about is deploying containers, deploying workloads. All of that idea of capacity planning and capacity, operations just goes away. It's purely working on your workload, purely deciding how you want to package up your application, and more application primitives rather than infrastructure.
Yeah, one of my favorite other areas, Olly, is in talking with customers. Once we're talking about today with EC2, there's a lot of management of AMIs, right? We've got to build those AMIs. We've got to every month we have to go patch those and manage that month over month. That's a lot of hours. And so in talking with customers, when we start talking about in Fargate, the OS is AWS's responsibility. We handle that. We're handling that patching for you. It's like a light bulb goes off at times and you go, oh, so I can get 10 hours a month back. It's like, yes, that's exactly what we're able to do with Fargate, and allow us to take care of a lot of that patching and maintenance piece that's there as well. In addition to a lot of the capacity management pieces, where instead of maintaining large fleets of virtual machines with Fargate, if you need more instances, you just scale. You tell us how many replicas you need. We make that happen. Conversely, and one of the most powerful parts is when you don't need all that capacity, either time of day or based on some sort of resource constraint, when demand goes down, we can scale that down. As soon as that container exits, you stop paying for it. And so a lot of the carrying costs or kind of maintenance costs go way down with Fargate, because as soon as that instance is exited, you stop paying as well. So it's got some operational and budget benefits that customers really like with Fargate.
Yeah. I remember in like a past life having to go through exercises trying to work out like how many containers were run on a virtual machine, and having a whole sizing spreadsheet like that just doesn't need to exist in the world of Fargate. It's great.
That bin packing exercise always reminds me of trying to pack my car on a vacation, get all my suitcases all sorted in, and bin packing is difficult, right? We want to make sure we have enough capacity where we can bin pack and get that utilization up on those nodes to save cash, but it takes a lot of time and effort to make that going, which can be challenging. From a use case perspective, over the last 5 years, we've seen customers use Fargate for all sorts of stuff. It's very much a general compute platform. I often get the question on, what's Fargate good at, or where should I use Fargate? And the answer is, anywhere where you need a container is a great starting point. And so I'd say some of the canonical examples, what we've seen pattern-wise with folks that are adopting is really starting with web applications is often kind of the first initial dipping the toe in the water, getting comfortable, running a proof of concept. For what you just mentioned, Olly, hey, we've got a web application, we have an API that from 8 a.m. to 5 p.m. we need to scale that way out, have lots of capacity. It's a pain to manage all of that. We need to scale that down after the fact. Fargate really excels in this by being able to more elastically deliver the benefit of the cloud for scaling out, scaling in, and making that a really smooth experience. So web apps are a great place to start with Fargate. Everyone's got lots of web apps running around as long as it can run in a container. And we run OCI standard compliant containers. So if it runs in a container, we can run it on Fargate. So there's not a particular language or framework. Bring whatever you got. Well, we love that with Fargate. Nice. And then I'd say kind of the second example we see a lot is around data processing is really emerged as a very strong use case for us. Especially things like queue processing or mixing in things like Airflow or step functions or things like AWS batch and EMR, any kind of type of scheduler where we need to go from 0 or few, scale way out to do parallel processing and scale back down. Fargate's great. With that capacity piece is there on demand. When we're finished running that batch job or that queue processing job, that expense goes away. And we can scale the number of replicas that we've got. We can scale that out or in based on things like queue depth. So when it comes to scaling, it's not just web requests. We can also scale in any of the metrics that are available in CloudWatch, giving a very flexible kind of platform to be able to run serverless containers.
Cool. I guess folks want to see it. Do we want to just try and just for a first workload on Fargate, see what happens?
Technical demos is the most thing what we hear for Olly, of course.
Awesome. Yeah, I guess just to kind of round off the what is Fargate piece is probably just a good idea to show it. So I'm just going to share my screen real quick, and hopefully it's all coming through.
You might have to change the. Yeah, there we go. Unless you didn't get in.
Bit of inception for a little bit.
Yeah, and you're going to have to make your fonts a lot bigger so that we can see. Yeah. There we go.
Okay. All right. Awesome. Okay. So as Steven mentioned, the way to interact with Fargate is through a container orchestrator. So here in AWS, we have 2 container orchestrators that you can use. You can use Elastic Container Service or ECS. Or you can use Kubernetes and you can use Elastic Kubernetes Service. Both of those, once you have a cluster created, you could just give it a workload, so give it a container image and choose the compute capacity as Fargate, or the compute type rather as Fargate, and we'll just run that workload. You don't have to provision anything for Fargate to use. You just give the workload to the scheduler and the scheduler will run it on Fargate. What you're seeing right now on the screen is a pretty simple ECS task definition. And this is just basically showing what you need to do to run a workload on Fargate. And so this is just a task definition where we give it an IAM role of who will be, creating AWS resources on our behalf. And we define our container, which is a pre-packaged container image with some environment variables and a port. And as Steven mentioned, we run any Docker or OCI compliant container images on Fargate. So anything that you can package up in a container, we can run. And you upload that to a container registry and then put the container registry in your task definition and you're good to go. Okay, so to actually start this workload on Fargate, what do you need to do? Well, I'm just going to bring up a bit of a terminal. Yep. And I'm just going to cheat and copy and paste the command so I don't mess it up while on a live demo. The first thing I'm going to do is, let me get in the right folder. The first thing I'm going to do is just register that task definition. So the command that I ran there was AWS ECS register the task definition, just so that workload definition is up in ECS. And then the second command I'm going to do is I'm just going to run a task. And I just highlight that whole thing and run it. That is just running a single one-off container. So AWS ECS run task. I want to run one of them. I want to run it on Fargate, and here's the definition that I previously uploaded. That's all I need. There's no auto-scaling groups there. There's no EC2 instances. There's no picking my AMI. You're kind of good to go from that.
Okay. Are there any limitations for using Fargate? For example, I saw that we're using some subnets or networks. I know that, for example, running on EC2, you have 3 different modes: is bridge, host, and I cannot for the life of me remember the third one. Anyway,
host or none or bridge. Yeah,
host, none, or bridge. Correct. And in Fargate, is the same? Does it work the same way?
No. So on Fargate, the only ECS networking mode is supported is the AWS VPC mode. It's this mode right here, and what that basically means is that the workload is then a first-class citizen in the VPC. So it has its own networking interface, it has its own IP address, it has its own security group, and which is a really nice, I guess, tight integration between Fargate and your VPC. So then you can go away and apply security rules with security groups. You can go and inspect traffic with flow logs. It's a nice first-class citizen.
Nice.
And so that's all I have right now is the dashboard. It shows my task is running. It was running a couple minutes ago, and that's it. That's giving me a workload to ECS and it running it on Fargate.
So there was nothing you had to set up from the VPC perspective, compute nodes. Everything was done just giving container definition and up and running.
Correct. The only slight prerequisite there was I needed to have a VPC. So I need to have a VPC because I need to pass in the ID of that VPC.
Of the subnets.
The subnets and stuff like that,
Okay. Yeah, so one of the answer to one of your questions there about some of the differences, or as Olly's deploying that task that's over into AWS, under the hood, it's EC2 down underneath the bottom. We don't kind of hide that. But one of the differences with Fargate that I really like is the security story. And so there's often folks will assume, so that task that I just deployed, is that co-located with other tasks from other customers or myself or other people? And the answer is no. So as soon as Olly deployed that instance on top of Fargate, that went into a dedicated EC2 instance underneath the hood for him. There's nobody else that's using that infrastructure, and so you don't have things like resource contention, right? So the number of vCPU and memory that you allocate, that is there for your task or for your pod in the EKS Fargate world. That's yours and only yours. So we deploy one and only one task or pod into that environment. There's no sharing there. Additionally, we have a lot of customers that really like the Fargate experience based on the security model is a bit different, right? So instead of co-locating lots of containers and us relying on C groups and namespaces for that isolation, we have that container isolation there, but we wrap all of that in that kind of that outer shell, that hypervisor that's provided by that virtual machine. So you're getting an additional layer of isolation, additional layer of security. As Olly said, if you want to access that container, you go through an ENI, through a security group. These very standard AWS constructs that we've had for forever gives you an additional layer of security for those workloads. And so for customers that are saying, hey, I really want to adopt containers, but our security team's a little concerned. That's not how we do things around here. Yeah. Fargate can be a really nice way that really resonates with that security team of saying, look, every container is wrapped in a VM. We have additional isolation. Fargate security model out of the box is also special. We don't allow things like privileged containers, which is a big difference. We don't allow extraneous Linux capabilities to be added in or any kind of interfacing with the underlying host mechanism inside of EC2. It's an additional layers of security that are baked up onto here. So Fargate's got a great security story, and it's one that we continue to evolve. And we'll talk about some of the ways that we've evolved that over the past 5 years. But job number 0 at Fargate and design tenant wise is very much around making sure we have a secure experience for you.
Yeah, and just to round off on this particular section, I just want to show what it was like from a Kubernetes perspective. If you're an EKS customer and you want to take advantage of Fargate, what does that look like for you? Well, it looks very similar. You go and create yourself an EKS cluster, and I'll show it in the console that I have an EKS cluster here I created. It's actually 123, and as of yesterday, 124 is out there, so I now get a nice little banner. And once you create an EKS cluster, you create these concept of Fargate profiles, which are basically just selectors. And there's a selector that I have here called demos that basically says anything deployed in the wildcard demo namespace, or any namespace that's -demo, anything that you deploy in there, send it to Fargate.
Okay.
Apart from that, everything else you do is just Kubernetes primitives. So you want to deploy a workload, you just write a pod in a pod specification, and you're good to go. There is nothing unique to this or custom to this definition. It's just Kubernetes YAML.
I don't see a lot of custom resource definitions, Olly. Where are those?
No, there's nothing custom or nothing that you have to add here to the YAML for the workload to run on Fargate. All you need to have is just one of those Fargate profiles that's either looking for a namespace or it's looking for a namespace and a label. In my case, it's just looking for a namespace.
Yeah.
And so you can see this is just a pod. It's got the image. One thing that we haven't called out yet, and I think we'll come on to it a little bit, is the way that you size workloads for Fargate. When you deploy a workload, whether that's an ECS task or whether that's a Kubernetes pod, you define the size of your container up front. And then depending on the size of your container, depends on the compute you get at the back end. So here, alongside my container, I'm saying it's going to need half a CPU, and it's going to need 768 meg of memory. And when you give that to Fargate, we'll choose a right-sized piece of compute to run that on.
Okay. And it's provisioned on the fly.
It's kind of given to customers on the fly, and ENI is attached, and it'll run your workload. Yeah. Okay. So if I kind of an example being, if I look at my cluster again, and let me just jump back to a command line, and I'd say like kubectl get, I don't know, let's say get nodes. Let's see what I have running. You'll see that I have a Kubernetes cluster here with 4 nodes running. Each one of those is a Fargate node. And that's because I have 4 pods running. And as Steven mentioned, there is a one-to-one relationship between a pod and a node. And we have quite a good security story because we're trusting a virtualization boundary between every container. So if I deploy that pod just real quick and let that go, you'll now see in the background we will go and get some new capacity, and we will run that workload for it.
Cool.
That'll take a couple of seconds to go, and when it does, you should see that then we go up from 4 nodes to 5 nodes when that starts running.
Mm-hmm. Yeah, so in the background, we're getting a new virtual machine under the hood. We're getting all the kubelets being connected into EKS. We're getting, if you wanted to use persistent storage and had a persistent volume claim there, we'd get all the CSI wired in with EFS storage. All this is being done kind of on your behalf without any additional infrastructure setup, which is really cool. Nice. And specific to Kubernetes, with the versions moving so quickly throughout the year, when it comes time to upgrade to that vNext version of Kubernetes, it's a pretty straight rolling redeployment of that workload, and you can be up and running with the latest and greatest versions for all that, which is fun.
Yep, absolutely. So that should be coming in now. So if I look at nodes, I should hopefully have a 5th node. I do. So I now have a new node's been added to the cluster, and that new node will hopefully be running my workload. Perfect. So that just kind of shows how I'm not having to manage any EC2s. I'm not having to handle auto-scaling groups or node groups. I'm just giving it a pod, and we're finding a place to run it for you.
Nice.
Awesome.
So I assume that Fargate, when we started 5 years ago, is slightly different or has a bit richer feature set than we had 5 years ago. So what has changed in 5 years? Give us the things that our customers have asked for and what we've given them and what capabilities we've allowed them to do and things to do on Fargate containers.
Yeah, it's a great question. It's a great question. So when Fargate launched back in November 2017, it reinvent the compute options that you had available to you is you'd be running Linux containers. You'd be running Linux containers on x86. You'd be running them on demand, as in on various pricing models. And at launch, the only I guess, scheduler you could use was ECS. And then for the past 5 years, more and more, I guess, compute options have come available to customers. So some of the big ones that have come out. So in 2019, we added the ability to run workloads on Fargate Spot, and customers are always looking at ways to cost optimize their infrastructure. How can they, I guess, cost optimize their workloads in AWS? And Spot is a great pricing model for that because it's running on spare capacity that we have in the cloud.
How much money can they say a customer save usually on Spot? We give them pretty.
Yeah, on Fargate Spot, we're kind of looking up to 70% discounts on demand pricing.
Yeah.
And the only difference that you have is when you launch a workload in that run task command that I ran before, or if you're using a service, when you create an ECS service, you would run it on the Fargate Spot capacity provider rather than on the Fargate capacity provider. Like there's no other changes you have to make, and it kind of really simplifies things a lot. When you use Spot on EC2, you have to worry about making sure you've got diverse auto-scaling groups. You have to worry about how you're going to ensure that there's always capacity in the auto-scaling group. You don't have to worry about anything like that on Fargate Spot. You just choose that capacity provider, and under the hood, we follow all of the Spot best practices to give you a running workload on AWS Fargate.
Yeah.
A few of the other compute options that's come out throughout the years. What else have we done? So we also launched Windows containers. So I mentioned we were Linux first. We launched Windows containers. So first that was Windows Server 2019, and then it was Windows Server 2020. So customers that are creating containers of Windows workloads, whether that is containerizing traditional .NET applications, whether that's .NET Framework applications, whether they're IIS web servers, whatever customers have containerized, they can now run those workloads on AWS Fargate without dealing with the overheads and operational pain of managing Windows Server container fleets.
Nice.
That's what we hear from. Anytime we say Windows containers, I always see an eyebrow raised somewhere in the room. But what we've heard is, yeah, exactly. But I mean, Windows containers are a very viable option for customers that are looking to kind of lift and shift and really may not have the budget to completely throw that app away and go redevelop that on .NET Core with Linux containers, but are looking to extend the life of existing applications, or in many cases, just, hey, we're running a lot of EC2 with Windows Server, and we're looking to operationally, that takes a lot for our team. We're 80% in on Linux. But Windows containers can allow them to kind of shut down those EC2 and have a common operating model of containers with the Fargate experience across both Linux and Windows. So often we hear, to Olly's point there around how we've been developing this roadmap, we love the Fargate experience, but we want Fargate for X. And so that's really influenced how we've been able to bring in things like Spot, things like Windows, that have unlocked entirely new workloads and use cases that have come into the platform with that same consistent serverless operating model that customers like. Yeah,
for sure. A few of the other things I just wanted to kind of call out on the compute side, which I think are really interesting. I guess last year we had the big Graviton 2 launch, which was awesome. A lot of customers are wanting to take advantage of Graviton 2, whether that's for the performance benefits, whether that's for the cost savings. Like it's a real, I guess, win-win from a customer perspective when they run those workloads on Graviton. And containerized workloads are often the easiest to move onto Graviton because they're often based on modern frameworks, and people can just build ARM-based container images really quite easily and quickly now on ARM-based MacBooks and emulation and stuff like that. And so, sorry, for 1 second, just to clarify for our users that might not be aware, what is Graviton 2? Graviton 2, yeah, good call. So Graviton is the second generation of custom ARM chips that we here at AWS make. So these are, I guess, some custom silicon, and they have a higher performance chip compared to some of the install instances. So when you run some data processing workloads, some encryption, decryption workloads, there's a whole host of workloads that really do well on Graviton and take advantage of that extra horsepower. And so customers that want to use that on Fargate, they absolutely can do.
Nice.
And especially for those that are those MacBook Pros with the M1 chips that are becoming very standard nowadays. It can be very easy. Just when you say Docker build on those laptops, you're getting an ARM-based image by default. In most cases, it can be very easy to be able to go from your laptop, your development laptop, all the way into the cloud with Fargate, all with the same system architecture. We see quite a few languages nowadays are very cross-platform. Things like Node.js, Python, et cetera, can be compiled to run either on x86 traditionally or onto these newer ARM-based environments through things like multi-architecture images, which is one way to do that. So sometimes can be a bit of an investment, but the payback for what Graviton 2 can offer from a performance to cost benefit ratio is pretty phenomenal. We're very glad to be able to bring that in a year ago. We've seen that great adoption this year of Graviton with Fargate.
Nice.
Yeah.
So besides compute, what else? I'm sure we have a lot of other stuff that we innovated with the Fargate for the past 5 years. So what else besides the compute do we have?
There's loads of good stuff. One thing I realized I do want to mention on the compute side, and because I think it's a super launch that we made a month or two ago, is we've actually now launched larger task sizes on AWS Fargate. Yep. So as I mentioned before, there are basically different t-shirt sizes of compute that you can choose when you run your workload. So like pairings of vCPU and memory. And previously, the largest container or largest task that you could run on Fargate was 4 vCPUs. And we were getting a lot of requests from customers that they had bigger containers in that and bigger workloads in that. And so one of the awesome launches we had a couple of months ago was the ability to run up to 16 vCPUs, 120 gig of memory inside of a Fargate task.
Can you say that again? How much?
16 vCPUs and up to 120 gig of memory.
In a container.
In a container. And right, as I'm a container purist, and this hurts me. Like I'm picturing like small microservices when I think of containers. But there are customers out there now that are running big machine learning models, big data analytics platforms, and they need horsepower. And so us be able to offer these big instance types is great.
Yeah, it essentially quadruples what we've been able to do historically on Fargate with these larger sizes, thus again unlocking new workloads. Even some of those kind of more legacy, Java type enterprise applications that are more monolithic in nature, but you're looking for some of the benefits of containers and a modern CI/CD stack. Those can run nicely in these larger 8 and 16 vCPU options. So quadrupling the horsepower available for Fargate has been exciting.
Yeah.
So sorry, that was one last compute shout out I wanted to make because I thought that was an awesome launch. Cool. Yeah. So a few of the things that's happened in the past 5 years, like what else is there to talk about? So we had some really interesting enhancements on the storage side, and as Fargate has gone on, as Steven mentioned, a lot of the things that we release is driven off customer demand and what customers want to run on Fargate. And one of the things that we found is that customers cared about either the local storage they had available to their task, whether that was a stateless piece of storage, so some storage that they're going to write to when their workload runs, and then they're happy for it to disappear, but they need quite a lot of space there, or whether that's customers that are starting to run stateful containerized workloads. And more and more people today are out there wanting to run stateful workloads in Fargate. And so we wanted to find a way to put state in or storage into a container that will live on once the task finishes.
Okay.
So things that I want kind of to call out, some of the things we did. So when Fargate first launched, Fargate only had a 10 gig volume to host the container image and a 4 gig volume to host any data. Quite a small amount of storage in today's standards. But if you picture like a stateless microservice, that's perfectly fine. That will work great. But where we are today customers can have up to a 200 gig volume attached to a Fargate task. It's customizable, so you can put in parameters to decide how much you need. But that really unlocks people that like download big data sets from maybe S3, process them, and then upload the results back to S3. But that they needed that scratch area, that place to download the data to do their their access, and having a 200 gig local volume really unlocks it.
Mm-hmm.
And then the other thing I wanted to shout out, and I mentioned it before, is the persistent storage element on Fargate. And one of the big launches we had a couple of years ago now was the ability to attach EFS volumes to Fargate tasks or Kubernetes pods. And whether this is on like an existing EFS share that you want to attach to multiple pods of the same service, maybe something to hold like a lock or a state between workloads in that same service, or whether this is just somewhere to hold, I guess, long-term retention data. And one of the interesting things that Steven mentioned on the Kubernetes side, on the EKS side, is this is the fully conformant CSI EFS driver. So customers that run Kubernetes are familiar with CSI, which is the container storage interface, which is like the main, I guess, storage driver standard that you have to follow. And from an EKS perspective, we have an EFS driver, which is the ability to natively provision PVCs and PVs, so persistent volume claims and persistent volumes, and get EFS storage for EKS.
Nice.
Yeah. One other thing I would just add, Ollie, is we talked about security earlier. Another area where we've evolved this ephemeral storage, which is the storage available within inside of that task, is that originally, from an encryption perspective, we got questions about, hey, we have very sensitive workloads. We have patient data, we have customer data, we have credit card data, we have very sensitive topics here. And so about 2.5 years ago, starting with platform version 1.4, that introduced that all storage on Fargate was encrypted by default. So that's a service managed key today, but essentially every Fargate task, all of that storage that we talked about, whether it's 20 gigs, whether it's 200 gigs, or anywhere in between, has that encryption out of the box. And so makes Fargate more attractive and appropriate for PCI compliant kinds of workloads, for healthcare kinds of workloads, for financial service types of workloads. And it's kind of yet another area where that security story gets woven in by being able to have that encryption for that disk.
Yep.
Yeah. Nice. Awesome.
So I assume our performance has got a little bit better as well over 5 years. I mean, computers have got a lot faster. We've got a little bit more gray or less hair on our heads as well because of that. But I assume we've done a little bit faster. We made some improvements there as well. All right?
Yeah.
Do you want to cover them, Steven?
Oh yeah. Sorry to hop in. Yeah. So I think when we started with Fargate, we started relatively small as far as like the number of concurrent tasks you could run at a given point. So that started way back at just about 100 tasks at a time, which again 5 years ago would have been a very large deployment. As we've seen containers and microservices really take off, the need for much larger task limits and better performance has become very apparent. So you've seen us every couple of years, we've been bumping that from 100, we went to 500, we got to 500, we went to 1,000. And so we've been moving up what originally were based on the number of tasks. And then you saw us this year, as we continue to evolve, we've made the decision to really switch those quotas from a number of tasks or number of pods over to a number of vCPU cores. So that better aligns with other enterprise types of software and other products that use that vCPU count as kind of the primary metric there. But then now, so that today, really vCPU quotas are how we're able to operate there. And these have, really from the earliest days have been soft quotas. And so if you're doing very large scale engagements with Fargate, we always encourage, hey, open a ticket, talk to your account team. In many cases, we can work with you around either architectural changes or just raising those limits up even higher from what the defaults are. Additionally, one of the things that's I think back in April of this year that we announced has been one of my favorite announcements is that we dramatically increased the speed at which Fargate can scale out. And so what we mean by that is if I'm at 0 and I want to go to 1,000, that used to be a much slower type of process. And we got a lot of feedback saying, look, we've got to scale faster, guys. We need to be responding in real time to our customers, to our demand, whether that's a website, whether that's a data processing app that needs more capacity. And so you saw us over the years make some strides there. But in April, we had somewhere around like a 16x improvement as far as how we're able to scale out there. And so that we had several blog posts. I think we even did a containers from the couch specifically around one of the container heroes, Vlad, that went in a lot of detail there. What that allows us to do is be able to scale out much more quickly and have a much more performant experience. And that represented significant work that the Fargate engineering team had done for over a year, trying to make that experience, looking at every component of Fargate, saying where can we squeeze out a little bit more performance and pass that on to the customer. And one of in Vlad's breakdown that when he was here, one of the things I remember thinking is, he's charted the performance over the years, and he made the point that, hey, Fargate every year is consistently getting faster and faster on the scale out. But as a customer, you've had to change nothing, right? I haven't had to change an architecture. I haven't had to change YAML or JSON files. Literally by running on a managed service, we're getting these benefits, for free, essentially. Those are benefits that are coming in that we can take advantage of. So that really speaks to the value of that managed service. And you're able to experience those benefits that Fargate and engineering team have put together there. So
yeah, for sure. Like it's quite funny when I've chatted to a few customers here in Europe, and they wanted to move their HPC workloads to the cloud, and they wanted to run some big batch processing jobs. And when you talk to them about the number of containers and tasks they want to start in seconds, it's incredible. And whether that's because they're using AWS Batch, whether that's because they're running their own schedulers, people today are really, really kind of wanting to get going quickly and scale out quickly. And so from a Fargate perspective, that was one of the things that we worked on. And as Steven mentioned, there was a big launch at the beginning of this year. Whereas now you can run you have like a kind of a burst rate of the number of tasks you can launch a second, and then how quickly we replenish that burst. And right now you can kind of launch at like 100 in the first second, and then that bucket gets replenished by 20 tasks every second that passes it. And when Vlad published his blog back in April, he timed it that he can get up to 3,500 tasks on ECS Fargate in just over 3 minutes, like just over 3 and a bit minutes. And that's a huge, I guess, undertaking what you're doing there, right? You have no infrastructure in your AWS account. You have no ASGs. You have no EC2s. And you just want to go out to 3,500 containers, and you're doing that in single-digit minutes. Like that's a crazy, I guess, scale-out workload, and that really unlocks some of those big HPC workloads, those big batch schedulers for AWS Fargate.
Absolutely, and this is one of those areas that we've seen as Fargate has grown. It's been awesome to see other services around AWS look at Fargate and being building on top or around what we were doing here in Fargate. A couple of years ago, we had the AWS Batch team come. That it's a managed service to be able to run those batch jobs you're describing. When we were released, we didn't have a lot of these performance benefits. We didn't have larger sizes, and so the feedback from customers was, "Hey, yeah, this is nice, but we need more." And so just in the last 6 months, having these larger sizes up to 16 vCPU, having that incredibly improved scale-out performance, now all of a sudden you have a lot of customers saying, "Oh, hey, actually AWS Batch with Fargate's a pretty interesting combination here." And so as the services have been evolving, you've seen benefits that Fargate has provided up to other services in and around and across the portfolio at AWS as well, which is fun.
Yeah, 100%, and completely serverless, that solution as well, right? You don't have to worry about your scheduler. You don't have to worry about your control plane. You don't have to worry about your compute. It's a real nice operational story there, and kind of putting that undifferentiated heavy lifting onto AWS to manage.
Yeah, absolutely. So yeah, Ollie, there's some other, from an integration perspective, just to keep that going. We talked about AWS Batch. Are there some other areas, or where are some of the other intersection points? AWS is a massive portfolio. I always feel like I'm eating at the Cheesecake Factory when with those big menus that they hand you when you sit down with all the different services around the cloud. Where are some of those intersection points? And as Fargate has grown, how has Fargate really grown those intersection points across the AWS portfolio?
Yeah. It's a really good story there around, I guess, how AWS Fargate and whether that's through ECS, whether that's through EKS, has been able to integrate with a lot of the AWS services out there. And so some common ones, some ones that we see a lot. So we see a lot of customers that want to run scheduled tasks or cron jobs, and they can do that using something like EventBridge and that new EventBridge scheduler that was announced beginning of this week, end of last week. And that gives you the ability to run workloads on a schedule whether that is a once a day, whether that's in every 5 minutes, and you can have these reoccurring timers. And when the timer goes off, what happens? You run that workload on Fargate. So you don't have to keep capacity around waiting for that time. You don't have to have some logic to spin up a desired count in an autoscaling group to run that workload. You can use those event bridge and CloudWatch events to really trigger event-driven workloads running on AWS Fargate.
Cool.
One of the other ones I actually really like, one of my personal favorites from an event-driven perspective, and this is, I guess, one of those things that when customers think of containers and they think of Fargate, they think, web servers, API servers, kind of that is the bread and butter. But you can actually run some really nice event-driven flows through AWS Fargate. And so one of my personal favorites is taking advantage of step functions and the step functions integrations with ECS and step functions integrations with Fargate. And that's actually one I wanted to show off. And so I'm sharing my screen now. Hopefully you guys can see it. Yep, a little bit of Inception. Awesome. So yeah, and so this for folks that don't know, step functions is kind of a workflow scheduler by AWS. And here I've created a state machine called.
Olly, I'm going to ask you to make your screen a tiny bit bigger if you can from the text, so we can see.
Yeah, no problem. Sorry, that's my problem. I'm too comfortable at home with a big screen. I always forget that when you share it, it's not as big. So this is an example of a really simple workflow, and you can obviously extrapolate this out with a whole host of other actions. But this just it shows what it can do. So here I have this very simple definition. On the left-hand side in the step functions UI and in the console, sorry, you have the definition in JSON, and they automatically render the workload for you, or the workflow for you. And so here you can see that I only have one action, and that action is to start a workload on Fargate. But there's some really nice things that you can do with step functions and that integration. So, and my personal favorite down here is this retry logic. When you run like a traditional microservice on ECS or EKS, you have a control plane, and the control plane's job is to make your desired count equal your running count, right? So if you want to run 5 instances of your web server, Kubernetes or ECS will constantly run in a control loop to make sure that 5 are running. Well, when you start to move to some of these event-driven flows, and when you're starting to trigger things off on schedules or trigger them off on queues and things like that, there isn't often a control loop there making sure that workload ran, and if it didn't run, trying it again. And this is one of the things that I like about step functions is this retry logic for Fargate, so that when I start this task, and if for whatever reason it failed, and that may be because of something I've done, that may be because of the data that's been ingested is a bit malformed or something like that. And this means that the step functions through the integration with ECS and run task will be aware that task failed and restart it for me. So if I just start off this execution, what happens? Well, you can input data. This is a demo, so you kind of imagine that this would be happening. Like a machine would be passing an input in here. I don't know, like a message from a queue or an ID of an order or something like that. But this is kind of like the input data to start off my step function. And then behind the scenes, what we're going to do is we're going to go off and trigger a task on ECS to run, or on Fargate to run that workload. So jumping over to the ECS console, you should see on tasks that I now have a Fargate demo 1 running, and that's going off and processing whatever was in my event. But that's just a really nice example, and I think the log even there you go. It outputs my input data just to prove that it got there. But it just shows how you can use like the AWS integrations that we have for Fargate for all of your various different flows, no matter what you're doing. It's a really a nice story there.
Yeah,
Cool.
very flexible to build whatever kinds of workflows you need, and yeah, all in a serverless fashion that pairs so nicely together there. Absolutely.
Yeah, for sure. It's like a workflow manager that you don't have to worry about. You're starting your workload on compute that you don't have to worry about, and then you also have like that like catching retry logic that is automatically out the box for you, so you can just have these event-driven flows and running in containers.
Yeah, I love the variety and options that we give you for maybe more of a spectrum option here, where hey, you could go write your own custom code to do this and put it in an app. We could use something like set functions to be able to give some very lightweight yet very flexible and powerful workflow pieces with all those tie-ins to the services. And then we can also use those higher value functions we talked about earlier, things like AWS Batch with Fargate, the EMR with Fargate as well. Just we've got quite a few ways, depending on what your application requires, what you need to be able to run. Exposing that as a serverless model underneath the bottom with Fargate gives you a lot of options to be able to build out your application depending on what you need to do.
Yeah, for sure.
Good.
Sorry, so stop my screen.
Yeah, great.
Awesome. Sorry, the joys of doing a demo. It's like I only have the one screen, so if I share it, I can't see what happens. It's a whole thing.
That's okay. We're coming on closing towards the end of our hour, and Fargate's been around for 5 years, and I'm sure we always say in AWS we're only getting started. What's coming in the future? Give us a bit of a sneak peek under what we're going to be kind of things we're looking at in AWS to do with Fargate.
Yeah, absolutely. Well, a couple things pop into mind, Mesh. I'd say first off, we do the Fargate team participates in a very open source roadmap that's on GitHub, the containers roadmap that's available. If there's something you're wanting to see in these next 5 years, please jump in there on GitHub. Let us know. Add details. Our product managers, our engineers across AWS, we're very we do watch those. We keep track of those, and the discussions we have internally directly reflect what we're hearing from customers, both through that roadmap channel and in direct conversations there. So the customer obsession is strong with the Fargate team, and you will see us go with where customers are wanting us to take the service. Also, to continue on the narrative that I was laying out here of really just steadily expanding out the kinds of workloads and the kinds of capabilities, I think that continues to be top of mind for us. I think you'll see us over the next year look at ways to go after yet more workloads that customers are saying they don't fit today. So one of which that I don't have details around this, but we're actively investigating, looking at what would GPU support look like inside of Fargate. Right? We talk to a lot of data science teams that say Fargate's great, we love it. We're not containers people, we're data people, but we need to utilize the componentry of containers and of orchestration to do machine learning model training, to do inferencing, to do these emerging new capabilities. So we have customers doing some of that today with things like CPUs, but it's a round peg square hole, right? You really want to have those GPU chipsets and the benefits that they provide. So we're looking at what would that look like, bringing in those types of chipsets, those GPUs into the Fargate experience, being able to provide value to a whole new persona, those data scientists, those customers that have extreme data needs there. So that's another area. Along with looking at how to evolve the pieces that we have here. So we have Spot, we have Graviton. How do we start mixing and matching some of these components together to provide kind of different price points, different flexibility, and different options for when you're operating those kinds of containers. So that's a big piece that we look at, is how can we really grow the types of workloads that can live on top of Fargate and be successful. And I think you'll also see us do quite a bit of a lot of the bread and butter, a lot of the classic things that you expect from Fargate as a managed service. So we just got done talking about that scale out performance and the immense leaps and bounds that we improved there. We're continually looking at how can we, now that we've got the scale out piece, how can we take that time down? it took Olly 45 to 60 seconds or so to get that container up and running. How can we continue to whittle that down and make Fargate faster? How can we hand that running container to you faster than ever? Are some of the things we're looking at. While also under the hood, continuing to modernize the fleets of servers that we run on, and just taking care of things behind the scenes that customers don't necessarily see, but they experience through things like the consistency of container performance, making things faster, more reliable. Those are all things that are actively ongoing at all times with Fargate that we will continue to do as we move forward, continuing to be better, faster, stronger for your containerized workloads.
Yeah, it always makes me laugh. Like the amount of things that, or different use cases and different variety of workloads that people run now in containers. Like, as I mentioned before, containers to me were started off as just microservices, stateless little workloads. They were fine, and now, as we've evolved and the technology's matured, people see the OCI image standard and container images as like the de facto way to package everything. Like whatever you're running, whatever like logic you have in there, whatever its job is going to be packaged up in an OCI container. And so what that means is they want Fargate to be the best place to run that container, right? And it's really interesting as we hear more about the different use cases and the different requirements people have for those workloads in Fargate, and making sure we listen to what people want to run.
Yeah, I don't even bat an eyelash at this point, Ollie. Like it used to be, you're running what in Fargate, but now it's like, yeah, cool, bring it on. Yeah, we love it. Yeah, we love the things that we see are always exciting because it's a testament to Fargate being flexible enough to be able to do a lot of different things. And so yeah, I don't even I'm not even surprised anymore when I think, oh, more power to you. That sounds great. Let's talk about what that looks like architecturally. Cool. So yeah. Yeah, and Ollie, you want to talk a little bit about what we've been doing around from a performance perspective? You know, being because Fargate deploys into a nice fresh underlying instance every time. We're not reusing old instances. So from a security perspective, you're getting something fresh. One of those downsides is, you know, we don't have a way to we have to pull that image from a registry each time. We've done some really innovative things around that this year. You want to talk about kind of what that is and going into next year, how we're continuing to grow kind of some really innovative capabilities there?
Yeah, absolutely. Yeah. So as Steven mentioned, like the one of the I guess the key features and benefits and awesome use cases you get with Fargate is that you have a brand new clean piece of compute every time. And so what that means is the first job that we have to do when we provision it is we download your container image for you. And that container image is normally living in a registry, and we'll download it and then run it. And a little bit to what I just said is, as time has gone on, the size of these container images are getting quite big as the workloads diversify. Like ECR supports a 10 gigabyte image layer. Like that to me blows my mind. That then you could have multiple layers in an image, and it's like this. What? Like that's anyway. So if we have to download that container image before we run your workload, like that there is an area that we can optimize. How can we be more efficient of what we download? And one of the interesting things that has happened in this space is some research was done a few years ago, and they realized that only a really small percentage of what is actually in a container image is actually needed to do work. And there was a really nice research paper that was published, and I'll try and find the link in a moment. And this shows that it's only like on average about 6% of files in a container image is actually needed for it to run. And so from a Fargate perspective, like why do we need to download the full container image to start if a lot of that container image isn't going to be used? And so this then brings us on to this concept of lazy loading. And lazy loading has existed in technology for a long time. It's how a lot of websites and web servers work, and it's something that is starting to come around to container images as well. And this is where we only download files from container images when we need them, instead of downloading the full image. And what that means is then we can start that container image really quickly because we don't have to wait for the whole thing to come down. A few months ago now, in the summer, there was an open source project released by AWS called Sochi, Seekable OCI. And Seekable OCI is a lazy loading technology from AWS that you can plug into Containerd, which is a popular container runtime. And then using Containerd, you can lazy load container images. Thank you. There's the link there, and that's a really, really interesting technology, and that's one of the things that we're working on at the moment and working into next year, and sort of as that technology matures, how we can incorporate that into some of the container services to really reduce the time taken to start containers and container workloads.
Yeah, super exciting area that we've wholeheartedly embraced container runtime and doing some really awesome stuff in the community with the Containerd folks and beyond. So just another area where AWS is contributing in open source groups and really making a difference here. So some really fun engineering. Glad to see the fruits of that engineering coming into Fargate as we get into the next year there. So
I will say this to a we are like we're building on the shoulders of giants here. There's a lot of great container image work being done. The StarGZ project, the eStarGZ project, are some really interesting and really awesome open source projects that have already existed around lazy loading container images, and we've kind of based a lot of our work off what they're doing as well. And as we contribute back to those projects and build on it with Sochi.
Absolutely.
So we're coming to the close of our hour. Firstly, I want to thank you both for spending the time with me, letting us all know more about Fargate, what we've accomplished over the last 5 years. If anybody wants to get in touch with you, how can they reach you? Would be the easiest way, Olly or Steven?
Yeah, it's a good question. So I will say I do have a Twitter account. I'm not that active on it, but okay. I do have a Twitter account. You feel free to DM me on there or message me via LinkedIn. Or I also hang out on a lot of the open source Slack channels. So if you go to the CNCF Slack channel, the Tarka Slack channels, the AWS Slack channel, I'm there as well, and I can push my alias on it.
Yeah, same. Yeah, Twitter, LinkedIn. Shoot me an email. I'd also say if for anyone that's watching that's going to reInvent here in a couple weeks, please stop by the Fargate booth, say hi, say happy birthday. We'd love to celebrate with you in person. We've got a lot of great sessions and breakouts and inclusion and keynotes. It's really that time of year again. So it's AWS Christmas as we get closer with all the new announcements and releases. So I would love to say hi in person if you're going to be out at reInvent. Otherwise, if we can do anything for you, please just reach out anytime. We're here to help make you as successful as we can be with Fargate.
And the same for me. I'm also going to be at reInvent, and you can find me on Twitter. Meishask is the easiest way to do it. My details here are also on the stream. Thank you again, gentlemen, for joining us. And here's looking to many more celebrations together on Fargate.
Awesome. Thanks for having us, Meish, and cheers. Cheers to Fargate. 5 more.
Yeah. Thank you.
Thank you. Thanks a lot.
Thanks, guys.
Bye.
Thank you.